Okay guys, we're going to go over Module 2, Topic 1 today, Angles and Congruence. Again, Module 2, Topic 1. The standard for this particular topic is GR 1.6. We're going to solve mathematical and real-world problems involving congruence or similarity in two-dimensional figures. Our objective today, you guys are going to identify and use angles, angle parts, and special angle pairs. Our essential question is, why are angles important in the real world? We'll start with the bell ringer. You guys would have worked there on this first thing in class. If you are making this up, pause, work this problem yourself, and then come back. Okay, bell ringer. Consider X is on line segment AB. If AX is 2x plus 3 and XB is 4x plus 7 and AB is 8x minus 70, what is the value of X and AB? So they're asking us for the value of X and AB. So I'll draw a number line here. X is on segment AB. Tell us that AX is 2x plus 3, that XB is 4x plus 7, and that AB, make this a different color here, AB is 8x minus 70. Okay, so as you can see, line segment AB, 8x minus 70. We have this portion, a to x is 2x plus 3, and xb is 4x plus 7. So let's just put our blue equation equal to our two red equations, because that's our whole line is equal to the two segments. It's going to be AB equals AX plus XB. And we'll replace everything here so we can solve for X. AB is 8x minus 70, or equal to AX, which is 2x plus 3, plus XB is 4x plus 7. Okay, so we're going to combine our like terms here. We have 2x and a 4x, it's going to be 6x. We have a positive 3 and a positive 7, positive 10. 8x minus 70 comes down. Let's subtract the 6x from both sides. I'm going to scoot this over here. So 8x minus 6x is 2x minus 70 equals, the x's, 6x is crossed out, and we got 10 on the other side. We're going to add the 70 to both sides. 70 plus 10 is 80. 2x. Divide both sides by 2. X is equal to 40. Now, they also wanted to know XB. XB equals 4x plus 7. 4 times, we got 40 for x plus 7. That is 160 plus 7 is 167. Sorry, I'm running out of room, guys. There we go. Okay, down below here, page 1 of this big new packet. Key vocabulary. Lines and portions of lines intersect to form angles. A ray is a part of a line consisting of a point on the line called the end point of the ray, together with all the linear points on one side of the endpoint. So in order to draw this, we'll just start with point A. If you had point B, you'd have ray, oops, didn't mean to draw it that far, AB. If you have C here, you could say AC. Two linear rays with a common endpoint are opposite rays. Opposite rays form a straight angle, which has the measure of 180 degrees. So let's say we have point B, and we have ray BC. And let's also say B goes this way, point A. So BA and BC are opposite rays. And this from here to here, so everything in between, equals 180 degrees. You also notice that's a straight line. An angle is a pair of rays that have a common endpoint. The rays are called the sides of the angle. The common endpoint is the vertex. Okay, let's say we're going to draw ray BC again here. Let's say we got a ray BA this way. So we'll notice that BA and BC, well, they have the same endpoint. Also known as the vertex. Angles are named by stating 3 points of one angle. 1 point from each side with the vertex in the middle. So like right here would be angle ABC, or angle CBA. We can go either direction. And also when you name the angle by just the vertex, it would be angle B. Points D, A, B, and C lie on the angle. Okay, D, A, B, and C. I'll just color this in, make it a little darker for you. Points G, F, and H lie on the, that's going to be the interior of the angle. The shaded part in here is the interior of that angle. Okay, I had to flip to page 2. You guys will still be at the bottom of page 1. My copy didn't print correctly. So, still looking at the same angle. I'm going to color it in like we had on the previous page. So, DABC are on this angle. Points I, J, and K lie on the, and that's the exterior of the angle. So before, where the angle bends this way, that was the interior, this is the exterior. Alright, you guys will flip to page 2. Number 1, use the figure to identify the angles or parts of angles that satisfy each given condition. Alright, number A. Name all the angles that have D as a vertex. Okay, so let's go in here and label D. So D is right here, and this is a vertex. We can start from EDG. So we got angle EDG. All right, opposite direction EDF. EDF. If you don't go all the way to F, you can still say EDB there. go this direction, we can say GDH. Let's see, flip the other side, and we can go FDC. And also go BDC. Okay, so HDC. Let's see, where have we not been? E, D. I think that's about it. 1, 2, 3, 4, 5, 6. I think that's it, but if you see any more angles, let me know in class. Part B. Name the sides of angle 2. Angle 2 is right here. So our sides of this angle are going to be BA going this way, ray BA, and then going this way it's BG. Okay, this angle is formed by ray BA and BG. Part C. Name a point in the interior of FDE. Alright, so let's choose a different color. So we'll go FDE. Name a point in the interior. Well, so this is our angle. This is the interior. I'm just going to do like this. We got one point in there. That's point A. Alright, part D. Name all of the points on the exterior of FDE. So FDE again. Let's see. Let's do this. FDE. Alright, so it says name all the points in the exterior. So we've made the interior blue, the exterior is red here. We have G, H, and C. So points G, H, and C. Let's get here. Alright, key vocabulary. Let's see, let me write this in and I'll get out of your way. Pardon, there's not enough room. So the measure of an angle is the measure in degrees of the space between the sides of an angle. Angles that have the same measure are congruent angles. I hope we do remember already, as many times as I've mentioned it, congruent and equal are hand in hand in this class. Equal goes with numbers, congruency goes with shapes. But let's see here. Let's say we've got an angle over here. We'll say it's QS. Let's say that this angle is bisected by this guy. I'm going to make both of these angles congruent, and we show that with the congruent arcs right there, matching arcs. Yeah, which are indicated on the figure by a matching number of arcs. 1, if we had 2, it would be 2. Okay, underneath, a ray or segment that divides an angle into 2 congruent angles is an angle bisector. So a little preview there. That angle bisector. So let's see. Paper looks different again. You guys should have a box right here. And so if this guy bisects that, we have this guy and this guy will be congruent to one another. Okay, bottom of page 2. In the figure, ray BA and ray BC are opposite rays. It's important. BD bisects angle ABE. So this guy, I'm going to bisect those. So if these two are bisected, we know they are congruent. Also know that because these are opposite rays. So these guys are congruent. Now they're telling us if the measure of angle ABD is 4x plus 14 degrees and the measure of DBE is 8x minus 32, find the measure of angle DBE. Okay, I'm going to scoop this down so I have a little bit more room to write. Now, so these angles are congruent. Because we know that the angles are congruent, the measures are equal, so we can put these two guys equal to each other to solve for x and then plug that in because they're asking for the angle, the measure of angle DBE. So let me go in here and write this. So, because these guys are opposite rays, because this bisects that, these two are congruent. So the measure of angle ABD is equal to the measure of angle DBE. Okay. Alright, so the measure of angle ABD is 4x plus 14. And then we're going to substitute that for the 8x minus 32 they gave us. Okay, first thing we're going to do, get x by itself, so we'll subtract the 4x from this side. 8x minus 4x is 4x minus 32. 14 comes down. Add 32 to both sides. 2, that is 46. 4x equals 46. Divide both sides by 4. Bring it up here so you guys can see it. It's going to make x equal to 11.5. Okay, but they want the measure of DBE. So the measure of DBE is equal to 8x minus 32. 8 times 11.5, that's what we found for x, minus 32. 8 times 11.5 is 92. Minus 32. The measure of angle DBE is 60 degrees. Okay, let's move on to page 3. Okay, page 3. Key vocabulary. Some angle pairs have special qualities that help us solve problems and find missing measurements. Special angle pair over here to the left. First thing we're going to talk about, and we'll talk about this a lot this year, is adjacent angles. Adjacent angles are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. So adjacent, another word would be like next to. Adjacent, like these two pins are adjacent, they're next to each other. Okay. Example over here though, let's say we got, this is angle 1 and this is angle 2. Angle 1 and angle 2 are adjacent angles. Alright. Next term here, a linear pair is a pair of adjacent angles with no common with non-common sides that are opposite rays. Okay, so let's go back to BA, BC that we had similar to earlier there. Let's say this guy, B goes that way. Alright, so these are opposite rays. Notice also opposite rays make a straight line. So if these two, let's call them, say angle 1, angle 2, angle 1, and angle 2 are a linear pair. Notice that's on a straight line. But either way, so angle 1 and angle 2 are going to equal 180 degrees. That's what this whole thing here, 180. So a linear pair. The sum of linear pairs measures, and it sounds like bad English, but no, their measures are going to equal 180 degrees always. Okay. Third, vertical angles. These are two non-adjacent angles formed by intersecting lines. So let's say we've got this line going this way and the blue line going this way. Notice that these cross and we have 4 angles. We're going to call those 1, 2, 3, and 4. So the non-adjacent angles formed by two intersecting lines. So for here, 1 and 4, so we'll say angle 1, angle 4, and then mark this with, well, let's go black here. 2 black marks here. So angle 2 and angle 3. These, and actually these are congruent. So 1 and 4 are congruent. We show the 1 arc each, and then 2 and 3 are congruent. 2 arcs, 2 arcs. And let's put over here that vertical angles, I should have put that first, are congruent. Okay, move down, page 3, number 4. It says find the value of x. So we have 2 intersecting lines here, which you still see at the top of the page there, that means those are vertical angles. And since those are vertical, this guy and this guy are congruent, so we're going to put 3x equal to 2x plus 44. And so we can solve for x. Subtract 2x here, 3x minus 2x is x, and that's going to equal 44. Number 5. Find the value of x. Again, we have 2 intersecting lines. These are vertical angles. So we're going to put these equal to each other. Let's change colors here. So we got 3x plus 6 equals 54. Subtract 6 from both sides. 3x. 54 minus 6 is going to give us 48. Divide both sides by 3. 3 divided into 48 gives us x equals 16. And as you guys know, in class, you guys do the you do. The idea is on the video here, pause when we get to the you do, and you guys work it, and then make sure, compare notes at the end. I didn't give you a chance to pause, my bad. Number 6 I'll wait a moment, ask you to pause, and then I'll do number 7. So number 6, solve for the value of Q. This is 3Q, and this is 15Q plus 8. Alright, so notice here we have opposite rays. This is a straight line. This guy here is cutting that line, but because this is a line, this whole thing equals 180. It's a linear pair. So we're going to put 3Q plus 15Q plus 18, so both of those equations equal to 180. Okay, so we got a 3 and a 15Q. 3 plus 15 is 18Q. That other 18 comes along and 180 comes down. Subtract the 18 from both sides. Move this up here. These cancel out. 180 minus 18 gives us 162. 18Q. Squeeze that over there. Divide both sides by 18. Q is going to equal 9. Alright, number 7. Try this, pause the video here, try it for yourself. Wait about 3 seconds, and I'm going to go ahead and work number 7. Hopefully you work the problem and we compare notes. If you're right, super. If you're not, let's see where you missed it. Come see me in class if you need to. Okay, number 7. Solve for x. So again, we have opposite rays. I'm going to do this. And this guy in the middle. So that means both of these are going to equal 180 because we have another linear pair. We're going to say 180 equals 2x plus 24. Plus this other guy, plus 4x plus 36. We've got a 4 and a 2x. So 2x plus 4x is 6x. We have positive 24, positive 36. You have those two together, you get 60. 180 goes with us. So we're subtracting 60 from both sides to isolate x. 6x equals 120. Divide both sides by 6. X is going to equal 20. Alright, bottom of page 3, it asks us to answer the essential question. Why are angles important in the real world? And if you look around, whether the classroom, wherever, anything you can build in the world requires the use of angles. Angles make up our doors, they make up our buildings, our floors, our windows, you name it. So anything you can build. Okay, page 4. Let me try to zoom out here so I can let you see what I'm looking at here. Alright, page 4, we have problems 1 and 2, and then you flip over to page 5, we have the next 3. So 5 problems on the next 2 pages. That's your independent practice. Let's work those out, and we'll compare notes at the end of the week. And let me know if you have any questions. See you guys in class.